All right, welcome everybody to the virtual meeting for the Nebraska and Iowa Splunk user groups. Today we'll have two different topics. Al will be talking on DSP and Matt will be talking on containers, where he'll be talking Docker and Kubernetes. Definitely change from being in person, being able to see everybody, being able to talk to everybody. Definitely not going to shake everybody's hand now like I used to or give hugs. So sorry, but I'm glad that everybody was able to still join us. We can still keep these meetings going. It's a lot easier for us being IT people. We're already used to working from home because at 2 a.m. we're not going into the office, or we've been working from home for a while. With that, I am going to turn it over to Al. Al, you should now be a co-host. You should be able to share your screen and take control.
All right, let me see if I can get it shared here. Actually, I'll do this. And all right, I've got some slides up. Can you see the slides?
Yes, I can.
Or a slide, I should say. All right. Well, thank you very much. I'm Al Liebl. I'm a staff sales engineer here at Splunk, and I've been with the company about 3.5 years now. Over the last year or so, I've been working with early adopter customers around DSP, our data stream processor product, as well as DFS or data fabric search. I was asked to spend a little bit of time with you, providing you some background on DSP and essentially provide a bit of an overview and a demo, and then I'll also get into a little bit of the architecture. Now, before I jump in, I do want to make a quick comment, which is, even though we're not in person, I'd love to make this as interactive as possible. So if you have any comments, if you have any questions, feel free to interject. I'd be happy to have a little bit of Q&A kind of peppered through the topic. Without further ado, let me get started. Let me get on the right monitor here. There we go. Now, let me say that I will cover a few things that are forward-looking statements as part of the conversation. I will try to be as explicit as possible about what is in the product today versus some of the things we're working on in the future. But I just want to let you know that, verify or double check the information that I provide if you're concerned about timing and availability. All right. So with DSP, Splunk has spent a fair amount of time with our customers, kind of understanding the new problems that they're dealing with, or the problems that they're trying to solve that have been particularly tricky. And we found that they've got tons of new ideas, new devices, new processes, new things that they want to try out. And obviously, there's all sorts of new technologies out there. Now, what we found from all of this, though, is that turning that real-time data coming out of kind of those systems, those applications, those devices, those ideas, those things that people want to do is actually really hard. And these are all similar issues that people run into with or try to solve using traditional Splunk enterprise. You've got lots of data, you've got a variety of systems, you've got different users, you've got some compliance concerns and things. So there's a lot of similarity here. But at the same time, given the technology landscape has evolved, for the last 15 or so years since Splunk Enterprise was originally introduced, we decided to look a little deeper and see, what can we do to try to help in this market and maybe take a unique approach. And the things that we heard from customers in terms of their criteria or kind of key areas of concern would be, first off, just being able to get their arms around all of the data that's being produced inside of their organization. And with that data, then be able to do some real-time data transformation. This is where you can look at removing kind of events that might not be too significant, so you don't waste time or resources dealing with it. Simple example here, I've got a log that's spitting out error, warning, informational, and debug. Maybe I don't care about the informational and debug messages. That's something that'd be great just to be able to kick to the curb. Similarly, maybe you've got some data that needs to be cleaned up. Having a simple centralized way to do that would be really great for most customers, and that's what we've heard. In addition, once you've got the data and you can work on formatting the data and kind of filtering the data, then what about actually doing something with the data even prior to feeding it to some other system like Splunk Enterprise or Enterprise Security? And that's where we looked at, what can we do to provide some functions or provide some activity on the data in the stream in order to generate value. Now, the next area is if I've got the data, I've filtered what I care about, and I can generate some insights. And let me actually backtrack for a second. When I talk about real-time insights, and let me say that, to be very clear, this is something that we're working on delivering and should be here in the next kind of release or two of DSP. But an example is being able to have alerting on the stream where you might have, let's say, an IP blacklist. And with that blacklist, you want to know whether or not you have anyone talking to a particular blacklisted host. Well, you can certainly search for that type of stuff in Splunk Enterprise, but if you're grabbing all of that network-related data, and in particular, maybe NetFlow data, where you've got a high-volume data source, and the value, if you're in an investigation, it's tremendous, but at the same time, if you're not actively investigating, it's an awful lot of data to wrangle and make heads or tails of. So that's where using a blacklist and being able to alert off that blacklist based on ingesting, at least into DSP, and not necessarily ingesting, but passing through that data in DSP, we can flag, or we could flag when we see a particular IP show up. And that's going to happen within milliseconds because we don't have all of the ingestion overhead. So it's a very quick way to give you kind of an early warning system. Now, there's another way that we can also get insights today, which is doing things like aggregating data. So if we use kind of that NetFlow or VPC flow log example, I might not want to pull all of that raw data into Splunk because of the volume, but if I feed it through DSP and I have DSP aggregated on 1-minute windows, then that's actually pretty cool because I get some visibility, but I don't have to necessarily consume all the resources that I would otherwise. And then one final one here for the continuous real-time insights is with one of our early adopter customers, we've actually worked with them and implemented a function, an ML function, to help them detect fraud based on data in the stream. So these are just examples. That's something that we are working on putting into the core product. But these are examples of some of the valuable insights and activities that you can do once you have data in the stream and you've got a kind of a workbench where you can start to operate on that data. And then the final point here is really around enterprise-wide data delivery. There's the pretty much cliche now that oil is data is the new oil. Well, that is true, but if that's the case, and it's really that valuable, then we need guaranteed delivery. We need to make sure that that valuable data that's going to help you run your business, that's going to provide you insights to a potential security breach, whatever it might be, that data is delivered to its destination with 100% certainty, and at the same time, do it at the scale and velocity to the variety of systems that you might have. So these kind of 3 core tenets were things that drove DSP from a product standpoint. Now, if we get into kind of some of a little more logical ideas that kind of how everything comes together, with Data Stream Processor, what we're looking at on the left-hand side of the screen, we've got your data sources, traditional stuff that's generating any kind of machine data. You would then send that over to Splunk DSP. And within DSP, we have a number of different concepts. There's a concept of a source, which is where data can come from. So that's what's on the left-hand side of the slide. We have a concept of functions. These are the things that you can do to operate on data, filter it, normalize it, transform it, aggregate it, format it, so forth. Those are functions, and that's in that middle chunk of the screen. And then we have a concept of sinks or destinations, and that's on the right-hand side of the screen, and that's where you send the data to. So conceptually, what we're looking at is getting that data from wherever it's being generated, feeding it through DSP and performing some operations on the data, whether or not it's kind of simple filtering and routing, or it's some sort of aggregation, or maybe some ML. And then finally sending it on to a destination, which makes the most sense for you. You know, high value data that you might operate your business, maybe that needs to go into a Splunk index for ease of investigation and kind of working with that. Lower value data, you might look to feed to kind of a data warehouse or something like that for long-term or compliance purposes, but not necessarily having to feed everything into Splunk. Now, the typical use cases that we support today, and let me kind of digress here for a minute. DSP is a fantastic product. From the perspective of the architecture that we've put in place, is really quite powerful, provides tremendous kind of scale and flexibility. You know, just in general, I think a lot of thought has gone into delivering kind of a great solution. That being said, because we are looking at a 1.0 release, the challenge right now is going to be more from a use case perspective and what we can deliver right now versus the things that we're working on at the moment to continue to add additional sources, things, and functions into DSP. So the use cases that I'm going to talk about here are really kind of based on the 1.0 version of the product, which is GA. And you will see these use cases continue to get filled out as new releases come out, because sources, sinks, and functions are a big push for things that we're adding with every new upcoming release. So when we look at the use cases here, we're talking about filtering and routing, or filtering and noise removal. So essentially being able to, let me stop for a second. I just saw something pop on my screen. Can you still hear me?
Yes, we can.
Okay, sorry. I just lost like the little Zoom participant window, so I'm not sure what happened, but I just wanted to make sure. Okay, so filtering and noise removal. So that's basically where you take, you know, maybe that log source that has error, warning, informational, and debug, filter out the stuff that you care about, and then kick the rest out to curb or long-term storage. Next one here is data routing. So being able to take data coming from whatever locations you might have it in, and then being able to say, okay, I want to send some of this over to Splunk. Maybe I want to send some into Kinesis for using somewhere else, or Kafka for using somewhere else. So really being able to route that data in the volume and velocity that you have. Data formatting. This one is interesting for a lot of folks because with data formatting, if you have, let's say, PII in your data, DSP becomes a fantastic way to be able to help with identifying where you need to mask that data and actually helping with that masking. It is something that it's still somewhat similar to working like with a universal forwarder, well, with props and transforms basically, to do the masking, but it's in a much more kind of user-friendly manner. And I'll show you what that looks like here when I get into the demo. But from a formatting standpoint, there's lots of things that you can do to manipulate the data. You can turn around and say, okay, I want to promote certain fields to index time field extractions and all sorts of types of things. So the formatting is really pretty powerful and pretty flexible. And then finally, we've got data aggregation. And with this, it's really around being able to take kind of noisy data sources and where applicable, look at trying to not analyze them from an individual event perspective, but look at it from, let's say, a 1-minute window or a 5-minute window perspective. And that way you can get kind of some summary information, if you will, that can still be powerful and useful in guiding that security investigation or guiding a business decision or an IT decision. But at the same time, you're getting it in a consumable manner that makes it easier for you because you don't have to deal with that volume, or at least not with that volume in Splunk Enterprise. You can deal with it in DSP and then figure out kind of where that data needs to reside based on the usefulness of it. All right, so let me go through some concepts here, and I'm just going to run through a few things. You'll see some screenshots, but we'll go through a demo here in just a couple of minutes. But from a conceptual standpoint, the first thing we need to think about is a data pipeline. This basically represents all of the operations to take the data from where it's generated, operate on the data based on what you want to do to it, and then write the data somewhere. Now, all of your data, it does flow through a pipeline inside of DSP. So literally, the pipeline is kind of the traffic cop for the data and determines what's going to happen to the data. Next one here is a source function. I mentioned earlier we've got the concept of sources, sinks, and functions. So a source function is really where we can read or receive data from. These use connections to connect into data sources. They can be both push or pull. So there's flexibility there. And the source function is really just meant to enable a spigot that data can start pouring through into DSP. Now, we also have a concept of a connector and a connection. The connector is really the know-how to connect to an external system. So in this case, you'll see we're connecting into AWS for SQS queue. Now, the connectors can be both push or pull based, and they can also be services that passively receive data. So the connector is really just kind of the plumbing to set up that source, if you will. A connection is a configured instance of a connector. So if we're connecting, let's say, to S3, it's the bucket name, you know, how I might authenticate to it and so forth. So the connection is just an instance of a connector that's been uniquely configured. Types of connectors that we have connector services. So this can provide kind of APIs for clients to send data to. The big one here is a REST API. But we also do have a forwarder service, so you can send data from universal forwarders or heavy forwarders. Or you could also write data directly to the Splunk firehose. Most customers these days are looking at forwarders and maybe the REST interface as it relates to kind of the connector services. Push-based connectors, this is basically where we'll connect to an external message bus and just have that data start flowing through. This is where we have support for Kafka, Kinesis, Event Hubs. And in this case, the concept of the Splunk firehose, that's kind of where we keep the data. That actually gets bypassed because we internally inside of DSP, and I'll get into this in a little bit. After the demo, I'll go into some architecture. But we use Kafka inside of DSP today. It's actually being transitioned over to Pulsar with our next release, but we use that as a message bus. So where you're actually already getting data from a message bus, we can pass that directly into the bus and don't have to use our own firehose. And then there are some pull-based connectors. This is where you'll have a schedule, you know, a cron job type thing to connect up to an external source. And each time they run, they'll connect and fetch some data. So the pull-based connections are really will vary according to, or will be used according to what's available from the system that we have to work with. Now, I talked about kind of source functions, or what I normally would just call sources. Well, we also have streaming functions, and I'm just going to talk about this more as kind of functions, but we do have streaming functions which are obviously different. But this is where you would do things like filtering, transform, or aggregate on the records. So every event coming into DSP is a record, and then streaming functions allow you to operate on those records. So this can be done either statefully or statelessly. And can be configured with advanced logic. So this is where using functions like this, we can have ML-based functions. We can have aggregate functions and all sorts of different types of more advanced functionality because these functions are all modular And I'll mention this now, but I'll go into a little bit more detail in a bit. The functions are actually built on top of Flink. They're really just Flink tasks that are executed as part of a pipeline. So longer term, the goal for Splunk is to have kind of a bit of a Splunk base, if you will, for DSP, so that you can also not just have the sharing of TAs or apps and add-ons for Splunk Enterprise, but actually have a location to be able to share custom-built functions as well as sources and syncs as applicable. All right, sync function, this one's easy. This is basically where do you want to send the data to. Writing it to Splunk is the typical default today. Now, we do have a concept of templates, and you can think of a template a little bit like a TA for a heavy forwarder. And this is really kind of a partially configured pipeline that can be used to create a new pipeline. It basically might have it would have the typical things you would expect to do with a particular type of data. So maybe you're looking to get VPC flow logs out of AWS, and maybe you're consuming those out of S3. Well, we don't have this today. Let me just be clear. But at some point, we'll look at providing a template for VPC flow logs coming out of S3. And with that, make sure that all of your field extractions are performed accordingly and so forth. Right now, this is an area that we're kind of playing a little bit of catch up on to try to start providing some parity with what we already offer with TAs and apps and things on Splunk base. So kind of a little digression here. I should note that DSP and the use of DSP does not eliminate the need or the usefulness for universal forwarders or heavy forwarders. It just gives you another option for how you're going to look to get data into Splunk. And I think over time, DSP will probably become more of the central kind of focal point, but the universal forwarder and heavy forwarder won't be going away anytime soon. So that's the reason why we're working on getting more templates built out to have some parity with the TAs. But it's not, it's not an end of the world situation for the time being, because we expect coexistence for some extended period of time. And probably because of the fact that heavy forwarders and universal forwarders can, access local file systems and execute, local scripts and things like that, they'll probably never go away, but it'll just be, another tool in the tool belt to determine what will be the best way to deal with the data that you've got. All right, let me switch over here to a DSP demo. Hold on, there we go. All right, I've got DSP up on the screen. Are you able to see DSP?
Yes, we are.
All right,
Yes.
great. Perfect. And by the way, let me pause here. I know I've been talking a whole lot. I've kind of thrown a whole lot out at you. So let me pause and kind of take a breath and see if there's any questions or any comments from anyone.
Are you going to talk about it with what infrastructure is required for that?
Yes. Yeah, we'll get into that in a little bit. All right. So yeah, bear with me for the brief demo and then some more slides on the architecture, and I'll finish up with kind of what the architecture looks like and the resource requirements. All right, so I've logged into a DSP environment that I currently share with kind of our engineering and PM team. So this is really kind of a little bit of a messy demo environment, but it still is useful for seeing how people work with DSP and what DSP looks like. And also we've got some data flowing through here. It's not the most exciting stuff, but it still is a good kind of test environment to play with. So inside of DSP, we've got the main screen here. And on the left-hand side, we've got the menu here to choose to build a pipeline or do data management. Let me start out by going to data management here. I think I might have left this logged in a little too long. It should be fine. Let me just refresh. Yeah. All right, let's try this again. I guess I should have sacrificed that chicken to the demo gods this morning.
I was going to make a comment. You may have had to go more better and not just the chicken, but if you didn't even do the chicken.
Yes. All right. Well, looks like we're back. Okay, here we go. Okay, so I want to start out here. I'm just going to start out with templates to begin with, just to give you an idea as to what it looks like. So what you'll see here are, we've got a variety of templates. Some of these are created by Splunk. And by the way, we have a full role-based access control model. So you can assign users different permissions inside of DSP, and that can help you limit what they can do and will determine what they can do. I should make note real quick of one of the use cases that I've had customer discussions around that people get pretty excited about is, especially if you have like active like development teams that are always like spitting out new logs and always needing a lot of attention from a data onboarding standpoint. As I go through here with DSP, keep in mind with this role-based access control, what other organizations are looking at doing is allowing those development teams to get their data into DSP and then create pipelines inside of DSP as to how they'd like the data handled. So that kind of takes the props and transforms and all of that kind of stuff off of the Splunk administration team. And then once they have the pipeline set up the way that they want, then they can request that it get activated. So then that data goes live and everything starts working appropriately. This is one of the ways that a number of organizations where they might be limited in terms of Splunk resources, but very active like development or IT communities in terms of sending in data, becomes a very interesting way to kind of make the process a little bit more efficient and a little bit more scalable. But a little digression there. So you'll see we've got some templates that are made by Splunk and then also templates that are made by different users. So you can save a pipeline as a template if you need to. And I'm not going to go into the templates for the time being. And for connections, this is basically where we have different types of connections. So you see you've got a Kinesis connector, CloudWatch, S3, Splunk Enterprise, SignalFX. And with any of these, we can also see what active pipelines we have going against that particular connector. Because keep in mind, the pipeline has a source with a connector and a connection, and then functions and a sink where it sends the data to. So let me just show you real quick here. If I go to create a new connection, you'll see these are the connections or sources that we support today. We've got Splunk Enterprise. We've got Amazon Kinesis. We've got Azure Event Hubs. We've got Kafka. We've got SignalFX and CloudWatch. There's also Amazon Metadata Connector and S3. And by the way, some of these we do with DSP 1.0 have a S3 source, but we're also working on an S3 sync as well that will be released as part of the next release. But in any case, this list is going to continue to grow on a regular basis. Let me just for simplicity's sake, we'll choose the Splunk Enterprise connector. And with this, you'll see we're looking for like a HEC endpoint URL, the token, and the connection name. So in this case, this is also the Splunk Enterprise, this HEC connection. This is something that's coming as part of our 1.1 release that's scheduled for the end of the month. But it's pretty simple configuration details. So just a simple example there. Pipelines, I can come here to pipelines and I can see all of the active pipelines and inactive pipelines. I'm going to try, let's see if, so I'm just looking for, there's actually another running one that I think is better, that has some, is it this guy? Nope, that's not it, sorry. I had a mask, it might be inactive. There's a masking example that I think is particularly good. Yeah, well, we'll try this one for the moment. And this is just meant to give you an example, and I'll show you how we can build one from scratch in a minute. But in here, in DSP, up at the top here, we've got the canvas. If you worked with Phantom, it should look pretty familiar in terms of the user interface. And really, you've just got kind of a flow chart that you're pulling together of what functions you want to have take place or occur on your data. Now, with this, we would start out with this particular one, reading from the Splunk Firehose, and we'll see there's no configuration required for this one. But then here we come to filter, and under filter, you'll see here we have a predicate. This is basically where we have some filter condition. Now, let me digress here for a minute. With DSP currently, the predicate here, if you can read it, it doesn't really look like SPL or anything like that. And it's actually DSL or a domain-specific language. And in particular, we're using Go underneath the covers right now. This is a temporary situation because at the end of the month, when we release DSP 1.1, instead of using DSL, it will be what we call SPL v2. Which is basically going to be leveraged. It's already a part of DSP and is being added into Splunk Enterprise as kind of the common set of commands and ways to search against data that we'll be able to work with. In any case, right now this is DSL, but it will be SPL v2, and in particular, you'll see that we're just looking to match the host name with Buttercup. Once we've got a match here, then we feed this over to another function, and in this case, we're extracting. And really what we're doing here is extracting the field names and as they come through in the data, and actually extracting those as fields. So I don't know, I don't have any live data on this one at the moment, but we'll pull a quick one together here in just a sec. So then we have a split filter up here where we're looking to see if it's a source syslog, then we'll actually continue down this path. And in this case, it's just writing to an index, and it would just end up being kind of the default. There's also a second split filter here where it's not equal to syslog, so all the rest of that data. We're then going to do an evaluation against that data. And in this case, we'll do mappings of field names. And then we'll look to do some aggregation on this. And this is where you'll see there's a little user interface component here at the bottom of the screen. Let me see if I can get this. No, I guess not. So with aggregation, you'll see the input fields here. These are all the fields that are coming from all of these functions that have occurred up until now. So we basically have all of this is the result. On the left-hand side here is the result of the function so far. The middle section here is what we're going to do in terms of aggregation. And in this case, we're going to take the timestamp, use the timestamp for windowing. We're going to do a 60-second window, and we're going to sum that that amount that we're receiving through the stream. And then it will be a tumbling window. So we'll basically get 1 minute intervals or 60-second intervals. And then finally, up here, we'll end up writing that out to another index. So that's really what kind of the process looks like, or what a pipeline looks like. But we can also create a new one. We'll discard those changes. Come here, we'll build a pipeline, and we'll start out. We'll just start out with like receiving from a forwarder. Now this is what it looks like to build a pipeline from scratch. So let's assume from this forwarder, I'm just going to get some standard data that I'd like to do some formatting on or filtering on. So I click on the plus sign next to my source function, and then here I can basically choose what I want to, what functions I want. In this case, I can use filter, but let me just show you the list. And this is something that's being added to on a regular basis. So we've got things like aggregate with trigger, batch events, batch records, bin, break events, drop fields. Some of these, by the way, are not in the current shipping product because I am working with a kind of a hybrid demo environment, but just it'll give you an idea for the types of things that we've got. So lookups, MB expand, merge. Lookups, by the way, is not something that is in 1.0 for sure. So, you know, good collection of things. So let's go ahead and just choose a filter. So with the filter, then I can come in here and basically put in what I want to filter And this is where using DSL, I can do, EQ, sorry. And, I could put in whatever I wanted to for that filter function. I'm not going to worry about filling it out now since we're a little limited on time. From here, I basically can turn around, add additional things that I might want to do. Perhaps once I've done some filtering, I want to do some fields. But I also, let's assume that I wanted to filter in 2 different directions. So I wanted to kind of branch this data. I can also click on the plus right here, and maybe I want to do some evaluation. I'll then get a new branch on my pipeline to be able to turn around and then do some evaluation of that data. From a field standpoint, you're not going to see any fields right now since I don't have any data flowing through this, and I don't know that I've got any good sample data, so I don't know I'll be able to activate it. But I just wanted to show you what the process looks like to set up a pipeline. It's really pretty easy, and we'll choose right to Splunk Enterprise. So, and here you can see I can save a pipeline and then kind of have it go from there. At this point, this is all I really wanted to cover from a demo perspective, really just kind of give you an overview as to how the pieces come together. I'll show you one final thing here just on an active pipeline so you can see what the preview looks like. I'm just going to try one of these active pipeline. All right, so we'll try like CloudWatch metrics here. So you'll see right now, I don't have any metrics flowing. Oh, actually I do. So here you can see what the throughput looks like, how many events per second are coming through, and then what that write looks like out to Splunk Enterprise. So if I had a more complex pipeline, when that pipeline is active, I'll actually be able to see the instrumentation on the functions themselves as to how they're performing and what they're doing. Okay, so let me jump back to the slides. And just a quick time check. Do I have another kind of 15 minutes or so, or is it another 5 minutes or so?
You got 15.
Okay, I just wanted to know how much time I've got to kind of dig into some details. All right, so back on the slides here. DSP, let me start out by saying DSP is a different type of architecture for Splunk than our other products. With DSP, basically it's a microservices architecture, so we're using Kubernetes under the covers, and we have a collection of open source and Splunk built components that reside inside of that Kubernetes cluster. Now, the main things that we use today would be Kafka as the bus. That's actually changing over to Apache Pulsar with our next release. And then we have Flink in there, and Flink is what the sources, sinks, and functions are written in, and how we basically work with those different systems. Now, with DSP, from a front-end standpoint, we've got UI controls. There's an abstract syntax tree generator for the functions and things that you've got. And then we also have that DSP configuration service. So this is all the stuff on the left-hand side of the screen. You can basically think about this as just kind of the plumbing and the interface for Splunk. From there, you connect into what really does the work, where you've got the data producers, so those sources feeding into Kafka, and then Flink operating on the data, all of that happening on top of Kubernetes, and then feeding into a Splunk indexer as a simple example. So if we kind of go a little deeper down the rabbit hole, I've got my different sources out there where I've got data coming from. I've got universal forwarders or heavy forwarders potentially feeding into our Splunk to Splunk service. So there is a universal forwarder, a forwarder source for DSP, as well as having pull-based connectors and like a REST interface to be able to feed data in as well, and even having that collect service. All of that data ends up feeding into our message bus, Kafka today, Pulsar in about a month. And any of your typical streaming data, that would actually go directly from a streaming standpoint into stream processing. So it doesn't have to go into the Splunk Firehose, but basically goes directly into Kafka. From there, Splunk will operate on that data, do whatever needs to be done on the data, and then there's the delivery service that's going to send it out wherever it needs to go. Now, once again, kind of going a little further down the rabbit hole, for data producers, you might have REST clients, forwarders, other remote data sources, or a message bus client. Depending on the data producer, that's going to determine whether or not it's going to be a push or a pull. For REST, that's going to be a push. The forwarder is obviously a push. For remote data sources, the LSDC there stands for large-scale data collection. This is where we're dealing with potentially getting like lots of data coming out of AWS S3 or other environments where you could really be dealing with massive volumes that need to be collected. So that today is a pull mechanism, but we are working on a push for that to really improve the scale and performance even more. And finally, your message bus clients, so your Kinesis, your Kafka, your Event Hub, that basically can feed directly into the external message bus for DSP. And then the top three are feeding into Kafka, while any message bus clients can basically just have that fed directly into Splunk for operating on. So that's what it looks like on the producer side. And lastly, as we get into kind of what we can do today with DSP and the architecture, what we have right now for supported data sources, they're listed on the screen: Kafka, Kinesis, S3, CloudTrail, Event Hubs. You know, you can see the list. But I want to reiterate that we are very actively working on adding new supported data sources, as well as new supported destinations and additional functions. So we've got the HEC source that is expected as part of our 1.1 release at the end of this month. And then we also have additional sinks and sources for S3 and additional kind of manipulations on existing sources and sinks. And I'll give you an example. One customer has asked for Kerberos-based Kafka sync because they need to have authentication. So that will be another supported sync coming in the next release. Now, I mentioned that this was a microservices-based architecture. So with DSP, the hardware requirements that we're talking about, first off, we do run DSP as part of a cluster, and that is for resiliency and availability purposes. Our goal is to guarantee delivery of all your data to where it needs to go. So we need a cluster of some sort to deal with potential issues. So with that, each node in the cluster is expected to be 8 cores. 16 is ideal, but 8 cores would be fine. And then we'd like 64 gigs of RAM or 128, basically 8 gigs of RAM per core. Because we are talking about streaming a lot of data and potentially working with some high volumes and velocity of data, we do want a fast, like 10 gig network connection. And then you want at least a terabyte of storage. Depending on your data volume, that might go up. And that's really just used for resiliency and redundancy purposes. If there's an outage for some reason, DSP can locally on that Kafka bus basically hold onto that data until it can be released. And if need be, if memory starts filling up, we'll start caching the disk. So there's some flexibility there. But with that, the default DSP configuration that we expect is a 5-node cluster. That being said, since we've started working with customers, we found that a 3-node cluster is acceptable for smaller environments. Now, let me give you an idea of what I'm talking about from a smaller environment standpoint. A 5-node DSP cluster, if all I need to do is filtering and routing of data, that is going to do in excess of 22 terabytes a day of filtering and routing on that 5-node cluster. If we're talking about aggregation, where aggregation has a more significant impact in terms of resources, just there's more computation that has to take place, a 5-node DSP cluster will do more than 7 terabytes of data per day, or throughput per day, based on doing aggregation on all of that data. So for smaller environments, if you have, let's say, 5 terabytes or less that you're dealing with, we can absolutely look at using a 3-node DSP cluster. It comes with a couple of caveats. One is that your resiliency factor is kind of limited a little bit more, just because each one of those nodes becomes more critical. But for some cost savings, that might be a reasonable risk. And the other item being that as your kind of data requirements and data volumes and things grow, you might start wanting additional CPU and things like that to be able to perform more operations in your pipelines, because keep in mind, you need the CPU for Flink to be able to execute those functions. So that's where over time you could grow a DSP cluster if you need to. So you don't necessarily have to start with 5. You could start with 3 and then kind of add to it as your needs grow. So I know I've just tossed kind of a whole lot out in front of you and covered a bunch of stuff. I think I've got another 8 or so minutes here, so we can have a little bit of Q&A and see if there are any questions or any comments, and happy to answer anything you might have.
So would this essentially be able to replace the Amazon TA that I have to install right now?
So right now with DSP 1.0, we can use, if you've just got S3 data, there is an S3 source so that we can pick up that S3 data, and it is simpler than using the TA. However, we do require more hardware with DSP than the TA does. So I wouldn't recommend using DSP just for that, but if you have other use cases, then that's absolutely one we can make better for you as well. And we are updating the S3 source and sync, just basically making a bunch of performance enhancements and improvements. So I think it will be an ideal way to work with S3 data before too long here. And I should kind of make a little caveat, which is prior to getting involved with the new product team here at Splunk, as a sales engineer, I was supporting AWS for, I guess, about 3 years or so. So I spent a fair amount of time in AWS, and S3 is obviously big for lots of customers, and getting the best performance out of that is a high priority for us. All right, other questions or comments?
So in high volume sites that do 100 terabytes a day, it looks like this works out to be 1 node per terabyte. What's the maximum number of nodes you want in your cluster for redundancy and manageability?
Great question. So right now, the largest customer we have, but they are not completely implemented, so I'll just caveat that, is 300 terabytes per day. Now, the interesting thing with DSP is it does scale pretty linearly, but it's actually, it depends on what you're doing from a function standpoint. That actually has the most impact to drive the number of nodes that you're going to need. And let me give you some context here. If we're doing simple filtering and routing, the functions that perform those tasks are really pretty minimal in terms of resource consumption. So in that kind of a situation, you're actually looking at like 4 to 5 terabytes per node of throughput. If we're going to aggregation, then you look at like a terabyte and a half, something like that. But no two pipelines are the same. So one of the things that makes it a little more difficult on myself and kind of my Splunk colleagues is we do need to work with you a bit more from an architecture standpoint to understand what you want to do with the data to then be able to provide kind of the right guidance. Working with 100 terabyte customer, if they just want to do simple filtering and routing, then it's pretty much just, okay, we'll take 20 or 25 DSP nodes and put them together, and we should be good. When we start talking about doing ML on the stream and things like that, that node count can certainly grow, but that's where we kind of have to do a little more analysis. The one thing that I will say that can help folks in my shoes from the Splunk side to help you understand kind of what that would look like in terms of resource requirements for 100 terabytes and so forth is if you can fill in the blanks to this question, then myself and my colleagues can help flesh out what the pipeline would look like in DSP. So I have, X kind of data coming from, X. So I've got syslog data coming from heavy forwarders, and then I want to do, X to it. So I want to filter it, sort it, route it, aggregate it, whatever, and then send it to X. And where I said X in that sentence, that's where we just want to fill in the blanks. And based off of that, we can build kind of a conceptual pipeline. And then we actually have a bunch of kind of calculators behind the scenes that can help us understand the impact of the functions that are being used to get a more reasonable idea as to the number of nodes required. So I know that was a long explanation, but hopefully that kind of gave you a little insight as to what it would take.
So would you have different clusters for the different types of loads you have? For example, a large site with mixed environments and mixed needs there, have one set for standard filtering and the other for the aggregation throughput?
So you don't necessarily need to differentiate DSP clusters based on workload. That's really not so much of an issue. The situation where I might look at having different DSP clusters is generally if I have, let's say, different data centers or AWS regions that I'm working with, because we'd like DSP to reside as close as possible to where you want the data to be delivered. Because our priority is, yes, we want to operate on the data, but we want to get it to where you need it to go because we expect you have some sort of a task or a job for that data, in addition to what you might do with DSP. So the typical reason why I've been working with customers on multiple DSP clusters is usually, they're in US East and US West, and we don't want to just put in one DSP cluster and have that sit in one location. We'd rather break it up based on their workloads and the way their data works. Now you can have one big DSP cluster as well, but it's more nuanced conversation regarding your kind of how your business is set up, where your data resides, and what you want to, how you want to handle that, and what your priorities are. So we could go either way. So once again, sorry for a long explanation, but just trying to give you a little bit more understanding as to why it is I'm saying that.
Yeah, thanks.
All right. So in general, if there's no questions, I do have a question for everyone on the call, which is, has this been kind of a useful overview? Did I cover what you're looking for? Just basically looking for some feedback to see. I will be presenting to some other user groups, and I'd love to make sure that I'm targeting things that folks like yourselves are interested in.
It does look intriguing. Our concern is that it's still kind of young, and some of our management might want to jump on it too quick without validating the process.
Yep, completely understood there, and I don't blame you for for being a little conservative. I think what I will say from my standpoint with DSP is if we have use cases that fit into kind of that sweet spot where I showed the 4 different ones up front, and we're dealing with sources and sinks and functions that we've got with the 1.0 product, customers are having success with it. But the real issue is if we have to go beyond the breadth of what we have support for today. All right. Any other feedback? Anything I missed, or was this pretty decent?
I quite enjoyed it myself.
This was good, Al. Thanks.
All right. Sure. All right. Well, that's it for me. Although the one final thing I will do, I don't know, in the invite, I'm not sure if my email address was in there. I'd be happy to kind of answer questions or get you connected up with folks if need be. You can hit up your Splunk account team for that, but in the chat window here, I will send my email address in case anyone wants to reach out.
And I'll also add that in the post-meeting email that'll go out.
Perfect.
All right.
Thanks a lot.
Yep. All right, I'll turn it back over.
All right, thank you. All right,
Sure.
I'm checking, finding Matt here. Oh, Matt is online. Let's just promote him real quick. Where'd he go? All right, Matt, you have been promoted to the co-host, so you definitely can share your screen now, so you can talk on containers.
Perfect. So yeah, let me get opened up here. So hey everyone, my name's Matt. I am a newly minted staff sales engineer supporting the sales engineers up here in Toronto, Canada. I've been a Splunker for 4 years and a longtime Splunk user before that. And today I'm gonna show you kind of just a quick flyby on a few of different topics that would come up when talking about containers, and try to do it in a kind of an easy way that hopefully will get you started as you're all likely bunkering down and might be tinkering in the lab over the next few days and weeks. And so hopefully this finds everybody happy and healthy. And so I'm going to cover a couple of different topics. The two major ones that I deal with customers on is there's some topics about running Splunk in Kubernetes. And so as you've heard from the previous presentation, you know, a lot of the newer products are bringing in Kubernetes as what we like to, or what we hear internally as a substrate, if you will. And so I would probably expect to see a lot more of that as we continually, you know, have the architecture maturing over the next few years for sure. So that I'm going to show you that side, a little bit of it, real quick piece. And then there's the getting data inside of Kubernetes. And so right now I'm just showing you a Splunk instance that's running on Kubernetes and then is collecting data from that same cluster that it's in, just as an easy way to demo it and as a way that you could actually get started with messing around and learning it as well. I'm assuming you can see my screen, so I'm just going to start from this dashboard here, which is just a custom dashboard that I built in Splunk app for infrastructure. Like in the traditional Splunk way, I just came into the dashboards panel and just started slapping things together, you know, based on what I wanted to see in the cluster. So this is that covers kind of like running Splunk in Kubernetes, and I'm going to cover a little bit of that. And then the data that I'm displaying is data that's collected from Kubernetes with Splunk Connect for Kubernetes. And I'm going to show you how you can get started with that. And that would be a very kind of Splunk enterprisey traditional integration where you have a collector in the Kubernetes environment that's sending data back to Splunk through HEC. I'll also do a quick flyby on some of the signal effects stuff because obviously there's some overlap there. There is a Kubernetes Navigator product that has been GA'd as well. And so if you are very metrics focused, or if you use SaaS products, or, you know, find yourself in an area where you're looking at something like signal effects, which is definitely for specific types of users, again, can run in SaaS, doesn't need, you know, FedRAMP, things like that. And it has a more metrics attack at kind of a very similar thing that App for Infrastructure is doing from a more entity and logging perspective. They both have pieces, and so I want to take you through them, and you all can see kind of what pieces are useful for you. I don't know how much Zoom magic I have here. I want to interact with y'all. So like, I don't know if they don't have the raise hands thing, right? Like this is not this is just a big room, right, Tony?
Correct.
Like people, okay, cool. So I'm going to assume that people have some knowledge of at least have heard the word Kubernetes before. Kubernetes is kind of the practical application of containers today that you're going to run into the most. Yes, there's Docker. Yes, there's ECS. Yes, there's other things, Rancher, yada yada. But the industry is definitely kind of, and ISVs or people, software developers and teams are delivering on top of Kubernetes, whether you see it there or not. So, for example, like in DSP, if you run that on-prem instead of a cloud service, it runs in a Kubernetes cluster, right? And so I'm going to show you around my cluster, and then we're going to look at two major projects. Splunk Operator, which is where if you're learning Kubernetes or you don't know Kubernetes, is probably the best front door for you, because what this is how you can deploy Splunk to a Kubernetes environment using some of the fun tricks and awesome options that Kubernetes provides as a cloud API. And then again, I'm going to show you Splunk Connect for Kubernetes. So these two major projects on GitHub are official projects. The Operator is kind of the evolution of the work we've done with Docker Splunk, and is really likely the only realistic way that Splunk could, release something on Kubernetes to a customer, because without that customer being a pro star with Kubernetes. And so similar to how DSP uses a Kubernetes underneath there that you don't really see, Splunk Operator could run in a similar fashion, where you could imagine a future where, if you can't run in Splunk Cloud for whatever reason, and you want to run it on-prem, that you could run it like a cloud, right? So that's one thing I'm going to show you there. And that is a alpha project, right? But it is built by Splunkers, with Splunkers, and the community and customers. And so again, I'd say you definitely want to take a look at this as something on the running Splunk in Kubernetes side, or hey, I wish I had a dev lab at work. We only have prod, or I wish we could, spin up some, versions of Splunk, to test or play with and then burn them down. So this is kind of, if you ever find yourself saying those things, or you want to learn how Splunk architecture works in an easy way, this is the project that you'd use for that. And is the project I'm going to walk you through, which is literally running this Splunk instance that I'm showing you here. Okay. I'm going to take a pause there. So again, on the running Splunk side, is there people here that have that as an interest, or is that too far out for most people that are here? Let me know if this is something you'd want me to double click on while I go along here. Okay. But anyway, just I'll let me know if you have questions here. Obviously, after deploy, I'm going to show you how I use this to deploy a Splunk instance for my lab. And then I'm going to show you how I deployed Splunk Connect for Kubernetes right beside it, and then pointed Splunk Connect for Kubernetes at the Splunk that I dropped in, and ended up here with a running instance of Splunk that has Splunk app for infrastructure, among other apps, that is getting Kubernetes environment data into it. Okay. I'm going to dig in there, but again, app for infrastructure is a free app that I'm going to show off right now that you can check out. I would say that the documentation is also very helpful if you're new to Kubernetes, or you've never really, or you're just a Splunk team and you don't know Kubernetes and you're just trying to help, the DevOps team deploy, or any of those kind of scenarios. The app for infrastructure documentation is like a good starter guide, or a good starting place for trialing this, or looking at it, or dropping it into a development environment so you can get used to it. So I'm going to show that real quick here, and then I'm going to show you how you can do it kind of more hands-on, or more kind of the manual way. So as you'll see here, Splunk app for infrastructure 2.0.3 is the latest release. You will see that there is two Kubernetes related, or container, actually there's three container related integrations inside of app for infrastructure. The first one is it can do some very simple Docker metric collection from Linux hosts when you do the Linux integration. But I'm going to focus on the two kind of bigger Kubernetes ones, which is Kubernetes itself as like, and that is kind of like your OSS open source brand of Kubernetes, certified, run, do it yourself, or, kind of cloud provider version of Kubernetes. And then OpenShift, which is just Red Hat's kind of enterprise hardened Kubernetes. They're the same. They're both connect for Kubernetes. There's just different, parameters that are at play when you deploy to each of these. Okay, and different kind of deployment methodologies. Okay, I'm going to focus on the open source Kubernetes one because I want to show you guys my lab and kind of an easy way to get started. Because a lot of this stuff is just like, you keep hearing the word Kubernetes and a lot of it is just kind of like hype cycle stuff or stuff you're reading. But like when you make it kind of tangible, you kind of see, oh, containers is just Linux, right? It's just a new way of thinking about how I deploy software to large Linux fleets or data centers, right? And so whether you're a Splunk admin or whether you're a DevOps team or whether you're just an IT admin, it's definitely something that has benefit for you, right? In kind of the reducing the toil and kind of 10xing what you can automate and do as a Splunk admin or a Splunk user, right? Or just an IT user, really. So again, if you're not sure what Kubernetes is or what, and you're, hey, listen, I'm just the Splunk admin. I'm just trying to help this team over here that says they need to onboard all this crazy new stuff they're using, then start here, which is the app for infrastructure, which allows you to go through a very simple onboarding process for both Kubernetes and OpenShift that you as a Splunk admin or you as a DevOps practitioner might not be able to answer all the questions here on your own, but if you come together, you most certainly will. And so to walk you through, like, what do I need in my cluster? What do I want to collect from my cluster? Where is my HEC endpoint? What token am I using? What, blah, 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 blah. And each step is laid out in the documentation in true Splunk fashion, right? You can go through each step, understand what we're asking you for, blah, 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 blah. Okay. And then what you do is you just kind of filter your way down these 3 or 4 steps, and it dynamically updates this script. Now, this script is not, let me put on my, positioning voice. This script is not meant to be an enterprise, replacement for automation. Okay. What it is for is so that you can deploy a golden image that works, and then you can go do all the crazy, I have to do it because they tell me 2 things that you need to do to get either Splunk running or Kubernetes running or both of them running. And so even if a customer I deal with is like very up on Kubernetes and they found Connect for Kubernetes on their own and they deployed it on their own because they know how to, use a Git repo and, they went crazy, I still bring them back to app for infrastructure because this script does a very cool thing that I'm about to show you. But I'm going to pause there for a sec. So I'm going to go deep into this Kubernetes integration to eventually circle back into, and sorry, Tony, how much time do I have?
You can go up until the 1 o'clock mark or 2 o'clock mark, depending on your time.
Okay, sweet. Okay, excellent. Okay, then you're getting the big flyby. We'll take the scenic route. So remember, a lot of what I'm about to show you here is nuts and bolts. It's toiling in the pits, right? At the end of the day, the outcome is what's important, right? And so where I'm going to get you to is the outcome that you can see all of your entities inside of the Kubernetes cluster, both at a pod level and at a node level inside of app for infrastructure, because this is an easy way for you to get started with the data. So many times traditionally in Splunk, like once that data gets in the cluster, you're kind of on your own, right? Like, okay, well, you got to go build some dashboards or whatever. And what I think is really key here is this can help you learn what's going on in the cluster and kind of make it more tangible. Like, oh, this is a GitLab container. What is it doing? What's coming out of it? Why does Matt run this? Blah, blah, blah. And so this app will allow you to analyze the behaviors and kind of the pre-packaged correlations we're doing for you without you having to go learn Kubernetes and then like SPL your way around. However, if you are a super SPL wizard, you can experience what I'm about to show you like this as well, right? Just like through traditional dashboards, right? Like if you know SPL as a second language, right? Or as a first language in some cases. So I'm going to dive into like what's powering this because, if you know me at all, and some of you might, so you might not, I'm about that action, right? So let's go look at a real demo, like it's actual running in a cluster. And so what I'm going to do is I'm going to jump onto this node. Now, to get started with anything I'm about to show you, whether it's running Splunk in Kubernetes or monitoring Kubernetes or both, I strongly urge you to pick up what's called micro Kubernetes or micro K8s. Now, there is many flavors of Kubernetes out there, many of them. And there's many ways you can go, but there's nothing I've used. And I've been working kind of in Kubernetes for about 3 years now. I've tried every flavor, Minikube, Minishift, Docker for Mac, Docker for Windows, blah, blah, blah. Micro K8s running on a Ubuntu server installs in a single snap command. And so I strongly recommend you to look at this as a way to keep distance from Kubernetes if you're just getting started and you don't really want to go in all the weeds, but still be able to kind of get started and play, so that you don't have to kind of, do it the hard way. You'll know, and it's a joke, right? Like Kelsey Hightower's a gentleman that's from Google, an evangelist, like has Kubernetes the hard way. Even he says, this is the easy way. If you want to do it, and again, we're all IT friends here. In IT, we could learn from maybe not choosing the hard way every time, right? And just maybe using the easy way. And then, then you can go break the rules when you know what the rules are, right? So everything I'm about to show you is a single Linux box that I paved over Christmas. And I'm going to shell into it here for a sec. Let's go here. So I'm going to shell into that Linux box that is my single Kubernetes node. In a cluster, you could have one or many nodes, right? I am running this single bare metal server in my basement. I live in Canada. It helps me heat the basement. It's a 12 core DL380, like generation 6, right? So it's fun because sometimes I go in and work with customers and my lab is much larger than their lab, and it's fun to make fun, to poke fun like that. But I got a lot of cores to play with here because I wanted to run a lot of things. And in the past, and you all might level with this, is this Linux box, this lab Ubuntu box. If I, as a practitioner, as they would call me, I'm installing software all the time. I'm installing it, removing it, breaking it, testing it, wiring it together, pulling it apart. And I kind of got really sick of the idea that I had to like hand care for this Ubuntu box, right? I don't care about this server. Like it's just my compute. And that really is the kind of the mind shift of going to Kubernetes, is that I don't want a Ubuntu box, right? I don't actually want that. It's like, you hear the, although we could probably find a better, analogy, the whole cattle and pets thing, that's a little gruesome. Maybe we could think of something different, but like, this node is just dumb compute to me. And that's all I ever want it to be. And so what it allowed me to do was, over Christmas, I reformatted the whole node because it was a RHEL or a CentOS box, and I was running Splunk manually, and I was messing around with OpenShift. I was doing a bunch of things. I paved over the Ubuntu box, right? It could just be a VM on your box. And I just literally ran this command. And Ubuntu's pushing it. You can see this is in the message of the day of the login to this Ubuntu server, because people are loving it, right? This is literally all you need to do to take that VM, run this command, and now be able to see your node like this. So what I'm doing here is, and I hope you can see my screen, I'll make sure it's big so that people can see it. I have now, by simply running that command, I no longer have to talk to the bare Ubuntu box. I just can distill it down to 12 cores and 96 gigs of RAM and a terabyte of storage, and I can talk to it through an API now, which is Kubernetes, okay? So if anybody, hasn't kind of looked at what the hoopla is about Kubernetes, this is what it is that I can come in now, and instead of like, how would I find out all the things that are installed on this server, right? Like I'm coming in, I want to, track what I'm running here. I can now literally drop in and say, hey, Kubernetes, or hey, node, hey, dumb worker node, show me what you are running, right? So for example, show me all the containers you are running, right? Oh, nice. Yeah, excellent. Yes, please take this poll. This is a choose your own adventure. I'm an 80s kid, right? And I remember growing up with the choose your own adventure books, right? Where hey, are you running Kubernetes on Amazon? Flip to page 45. Like that really is the life right now, right? And so you definitely have different personas, different people at different areas of the journey. So please bear with me as I try to make it interesting for you at least. And the best way I can do that is from a Splunk admin perspective. And yeah, perfect. Thank you for doing that poll. That's amazing. I'll keep watching that as we go. But basically what you're seeing now is, and the poll results, even just from a glance, is very similar to what you're going to see in the market right now. You're hearing a lot about Kubernetes because a lot of your technology strategy teams or your engineering teams are looking at it for net new or next level projects. Doesn't mean it's going to replace your 5,000 RHEL 6 boxes that run, you know, old school stuff or whatever, but it is definitely the bridge between the two, right? You know, if you're a Red Hat shop, your new stuff's going to run on OpenShift. Your old stuff's going to run on Linux. You know, if you're a non-Red Hat shop, you're going to pick a cloud provider and then run in your private cloud, right? So everybody's kind of there. And so, yeah, perfect. So a lot of interest in it. You know, people are starting to play with it in dev and some people that are in production. So perfect. So again, I want to try to break down some of the stigma around, or not stigma, but like some of the mystification around it, because even as a Splunker, you know, I'm a friendly here. You know, we're all Splunkers here. I came to Splunk because I was at a telco and I thrive on new tech. I love it. I love going in there as a Splunker, you know, diving in and looking around and bringing all that data back to Splunk, right? And telling that story. And so this is kind of the best way I could maybe show it to you. So for example, if I had came to talk to this group last year at this time, in order for me to show you my Splunk instance, I'd have to be on this shell, this lab node, and I'd be dealing with Splunk D, right? That's like legit running on this box with everything else. Now, if I say, show me all the pods, and again, for all intensive purposes, a pod in your mind, if you're new to Kubernetes, is a VM. And I know people are cringing, but follow me here. For the easy initiated ones, think of it as a single IP address, a single port that is, it could be made up of many containers behind it or many processes. Usually it's only made up of one or two. That's why they call it a microservice or something. But like, that is an IP, that is a single compute entity, right? And so when I say to my server now that it can speak Kubernetes, when I say, give me all your pods, I'm basically saying like, show me all the, you know, the packages of code that are running on here, all the VMs, quote unquote. And I know people are cringing, but I'm just trying to bridge the gap here. So, because they are not VMs, but again, in theory, they are a one single IP, right? And so if I take a look at all the pods that I'm running on this cluster, you can start to see some of the reduction in toil and the reduction in management that I'm simply displaying here because, oh, look, here's my Splunk. I know how long it's been running. I know, you know, is it up? I know, oh, here, look, here's my Splunk Connect for Kubernetes stuff. I know how many nodes, you know, this would be like a equivalent for you to like be able to go into your work at Splunk and like dive into an API and say, show me all my nodes, right? Without having to go into a UI or go into, you know, some hacked together shell script, right? Like it would be a native experience, right? And so it gets better. But this is kind of the magic, like the core magic behind what Kubernetes is doing is, as you can see, as a Splunk admin or somebody who wants to get an outcome done, I want to get code running so I can get to an outcome. I can abstract a lot of the stuff that I don't care about this Ubuntu box, right? Like I don't patch this box. Like my platform team does that, or you know, like my platform team worries about that. I'm a developer. Or I'm just running an application on this node. I just want to, you know, an easy way to run my apps on top of this dumb compute. Okay, and so that is the kind of the 5-minute, you know, intro christening to Kubernetes and like why it's a big deal. And the other half of that, so again, I'm you know, management, the ability to programmatically manage this entire compute cluster, whether it's one node or 1,000, you know, to be able to schedule all of these different little tasks. You know, I'm running Splunk here, I'm running collectors here, I'm running Nginx, I'm running GitLab, you know what I mean? Like to be able to nicely compartmentalize all this code and now be able to tightly pack it and manage it onto my compute infrastructure. Okay, so I'll stop there. I'm gonna answer. Can I answer these? Share polling results. Okay, no, okay. So cool. So yeah, so a little bit of everybody interested. Somebody in dev. some in production. And this breakdown is probably pretty accurate to where the general market is. I would say that if I map this kind of response to the larger markets that I work with, like all the customers I work with, you'd probably find about the same thing. 10 to 12 to 20% of our, new cloud initiative customers, or storefront or e-commerce customers or bank customers. And so the customer and the type of code you run and the kind of developers you have, it all makes a big difference here, right? So I will tell you this based on the numbers here. If you do mobile banking, you run on Kubernetes, right? If you have a bank that has an app that runs on a bank front end, chances are it's running on a Kubernetes environment. If you play Fortnite or someone in your house plays Fortnite, it runs on container architectures like Kubernetes or Docker, right? If you buy shoes online, it also does. So again, while it might be only a small subset of us that are running in production on our projects, usually those projects are the ones that are leading that cloud charge, right? They are customer facing, they need scale, blah, 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 right? That'll just be my, diatribe on that. Okay, I'm gonna take a big deep breath. I wanted to just cover Kubernetes as why do I care? And the answer is you don't, probably. What you should care though is you do generally care about deploying software in a very easy to get started manner. And so that's what I'm gonna cover now, right? So I've shown you kind of around my node, here's my lab. Now let me show you what I did to get to the outcome of running Splunk on Kubernetes, but then also running, my blog. For example, if you want to see some live data, if you all, hammer your browser and go to mattymode.io, you'll hit a pod. This website is a Kubernetes pod or a container, right? And it is running on my compute node, right, on my premises right here, right? But it's also fronted by a network load balancing logic in Nginx that comes in here. And so I'm going to walk you through all that data and how you can hit that website and track it with Splunk by using the data that is coming from these pods right here, which is Splunk Connect for Kubernetes. So, and then it's all going to send that data to this Splunk instance. So let's look around that a little bit closer for a minute here, and then we'll get into Splunk and mess around, and then I'll take some questions. So what I did to get started was I needed Splunk, and if you want the long form, version of this story or this presentation, just go each blog post one by one is literally how I built my lab. This covers how I steamrolled it and installed Kubernetes. Here's how I actually, used a USB key to install Ubuntu. Here's how I deployed Kubernetes. Here's how I deployed my website, blah, 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 right? And all of this is just a place that I can brain dump so that you can kind of get, a little bit deeper, more kind of technical information about how I made all this demo work, right? So the first thing I did was I had that Kubernetes cluster and I needed Splunk, duh. So all I needed to do that was deploy the Splunk operator. The Splunk operator is, there in Kubernetes, there is an operator framework that is amazing for people like Splunk, right? Software developers or service providers, because they aim, and I'll just kind of, read it right from the docs here. And if you don't know, Kubernetes.io is the official documentation for the project. So you'll definitely want to, Google that there. But the operator pattern aims to capture the human operator who is managing a service or set of services in the code. Okay. And, any Splunk administrator, you should feel seen when you hear something like that, right? It's like, no, Splunk, I shouldn't have to learn all the things about Splunk to become a guru so that I can use Splunk properly. Splunk should just encode the knowledge into the product, right? And yes, it is a nirvana statement. It is something that people are working towards, but it is why a lot of people like cloud providers or Splunk or anybody else would aim to use Kubernetes, because they want automation to let the repeatable tasks take over, so you can spend your time playing with your data, splunking in the data, creating the insights that actually are why you would use any of this stuff, okay? And so what it allows us to do is to build a solution that allows you as the user to just ask for Splunk. So what does that mean? Well, when I deploy the operator, which is literally a one line install. So if we go to Splunk operator, and you hit this repo, there is some really great docs. You just hit docs and then just take a stroll through getting started with the operator. But if I boil it down for you, I already have a turkey out of the oven. You legit just run this command. That's it. Now, I know there's some of you like, yeah, but what does it do under there? Fight that urge. Fight that urge, because all it's doing is installing Splunk. That's what you want it to do, right? It's actually installing an API layer that will allow us to ask for Splunk. And we could, actually run Splunk kind of like a cloud, right? Where I could say, hey, I want one instance, or I want a cluster, or I want 6 clusters, segregated clusters, right? Or I want to run or try out DFS. So the Splunk operator will actually have the encoded knowledge in it to deploy Splunk, whether in a standalone or in a clustered topology. And it would also allow you to enable DFS and hopefully one day the Splunk Connect for Kubernetes. But this operator pattern is what you want to kind of start looking at as the realistic way that Splunk could run on Kubernetes on-prem. Okay? Because I'd be honest with you, right? Like, this is only interesting if you're running Splunk yourself. Like, ideally, you should just be wanting to run in the cloud. Let somebody else run that for you. But we all know the world is gray, right? And that's not a possibility. And so the next best thing should be, hey, I have a bunch of compute on-prem or that I own, and I have Kubernetes installed. I want to take advantage of all that easy stuff that Matt was showing me. And so let me show you what some of that easy stuff looks like. So after you run this command, which if you just follow let's just follow this URL, right? So and remember, kube control is the way that I interact with my cluster, right? Kube control, get nodes. Kube control, apply configuration. Kube control, blah, 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 right? So kube control apply is how you install something on the cluster. Like, it's going to apply configuration to the cluster. And if you follow this link, you're going to download a configuration, or you can actually look at the configuration if I put it in like this, I think, or HTTP. Actually, let's just download it. Save it to downloads. If I open it up, you'll see that it's a YAML. And when I open this YAML up, it is a definition for Splunk. So this is literally exactly like you downloading Splunk off of Splunk, right? And installing it with a tarball. It's just that now you can actually open it up and read it as a human, right? You can see that we are installing, a custom resource definition in the cluster called Splunk or standalone, right? And so this is kind of in the weeds and everything. But when you run that one-liner command, that you do is you end up with this container running, which is the Splunk operator. So you generally would run there's 2 ways you could deploy this. And think of this as like your friendly neighborhood Splunk admin in a box, for real though, right? Where this will be what you would ask for when you want to install Splunk. So this operator pod, it just runs one pod in a namespace. For example, if you wanted to segregate your users as an MSP or as somebody who's running Splunk as a service, or if I just wanted to run one operator, it can deploy all the Splunks in the cluster. But usually we run one operator per group, for example. So like, let's say I'm working with Tony, me and Tony are going to go deploy Splunk, and he has Kubernetes. Then I'm going to say, okay, can you make us a namespace called Splunk and then deploy this operator? And then once that's done, that will have our ability to do crazy things like this, where I can take a configuration that looks something like this, and I'll show you a Splunk sample configuration. So these are YAML files. These are like your conf files, in Splunk lingo. And if I look inside the one called deploy, right, Mattimo Splunk deploy, let's take a look at what Mattimo deployed. This is now what the operator allows you to speak the language of. Hey, operator, I want one Splunk. I want it to be running 801. I want it to use this license. I want to have this much storage. I want this to be the password. I want to install these apps, make it so, right? And so I literally, to install Splunk, I just apply this YAML, and then this pod spins up, right? This Splunk standalone pod. So you can see here, I'm asking for a Splunk instance, Splunk Enterprise. I'm asking for it to use this container, and I'm asking it to, mount all of this configuration so that the outcome is when I go into my Splunk environment, so which is now a Kubernetes namespace, ta-da, I have a standalone Splunk, okay? And so one thing you would probably never do in old school Splunk if you're doing a demo is legit blow that Splunk instance away, because I mean, hey, look, I'm showing you this Splunk instance. Why would I want to like destroy that Splunk instance, right? But you could, in theory, like I could just legit blow this away, and what Kubernetes is going to do is going to put it one right back in its place with all the same specs that are in here, because I have asked the cluster to ensure that there is always this pod running. When you talk to Kubernetes, it's like you're saying, hey, schedule this Splunk instance and make it like the Terminator. If somebody tries to kill it, bring it back. It must always run, right? And so Kubernetes says, okay, and it takes that and it takes care of running this Splunk instance where it makes sense. So for example, if I had like 50 nodes in my compute cluster, I can do things like get pod, watch this. So if I can say, where is this pod running in my big compute cluster? I can say something like kube control get pods and show me like some more wide output of it. And so what this allows you to do is, like I was telling you before, this is the kind of view that you could never really get as an admin, where I know where all my Splunk things running. I know exactly what IP it's running on. I know how long it's been up, and I can configure it and manage it from here, right? So now that my Splunk instance is up, I was able to go then deploy Splunk Connect for Kubernetes, okay? So that operator, again, super easy to use. When you deploy that operator, you can then ask for instances of Splunk. You would then end up with an instance of Splunk that this operator now manages. And so the long-term idea is that this operator would be how you upgrade this. This is how you would change the version. This is how you would, configure it, really manage it from a high level, okay? And so if Splunk does, go down this path and it becomes a GA thing, instead of us having to like beat you over the head with best practices, we would just put it in the code. You won't even have to care about things like, how to, configure buckets and how to mess around with scale, because this operator will deploy Splunk with best practice in mind for running in a containerized environment, right? So you will just ask for things like, give me three search heads, 3 nodes, it shall be done, right? Give me, scale that to 20 nodes, done, right? And so that's what that Splunk operator project is, kind of where all the work is coming from. And the demo that I'm about to show you is all built on top of it. Okay, so this Splunk instance, the website, this website that I'm going to hit to generate some traffic in Splunk, my GitLab instance that if you all want to play with me, you can come here if you go to mattimo.io/code. It's that GitLab pod I just showed you, and you can, I have this register thing here. You don't have to register if you don't want to, but like I had to lock it somehow. I didn't want to just like have all the code public. But there is some public code that I host here that runs on Kubernetes, right? And so this allows me to build a very awesome demo for you here, which is, this is live, this is, me starting, to log in preparation for this talk. And this is me, creating traffic all along the whole time that we've been talking, right, in Splunk right now. So I'm going to cover more of the Splunking the data side now as we kind of come up on 20 minutes left. So I'm going to take a big deep breath, but basically what I want you to leave here with is, don't worry about being a guru of Kubernetes. You don't really need to know that. Check out Splunk Operator as your front door to why you might want to learn Kubernetes. Because again, Kubernetes you won't care about in a couple of years, but the things that it enables, you will. You definitely will, right? And so this is a great way to start looking at, hey, maybe we want to start, get rid of that old crusty heavy forwarder tier, and we want to run, a Splunk Operator managed tier of heavy, scalable heavy forwarders. Or maybe I want to run my search heads in there. Or maybe I just want to run my development lab in there and run a 10 node cluster that I never was able to before because I could never get 10 nodes, right? And now I can just go run it in the cloud, right? So check out Splunk Operator. check out Mike Dickey and the work that the team that's Docker Splunk has done. If you're not really ready for Kubernetes and you just want to mess around with Docker, check out Splunk Docker. It's all the same team. And I'm going to kind of let that lie now for a sec as we go into a more traditional kind of Splunking Kubernetes mode. But I'll take a deep breath here. Any questions on like, I know there's probably a lot of questions, but any burning questions on like why you should care about this, why you should look here, and any plans of like, what Splunk's plans are, or anything like that I can answer? There's a great facts here, for things like that, like to answer some of the general ones, like, when are you going to support all this, Matt? When is it going to be GA? Why would you even bother with any of this, right? So there's some kind of facts here on the doc, on the repo, but I'll take a deep breath. Any questions on starting to play around with running Splunk or learning Kubernetes with Splunk? Cool. I'll let people fight the mute for a sec and take a sip of water. But basically, that is the front door you want to go in. If your concept is, hey, I'm looking to like reduce the toil in my life of being a Splunk admin, and I can't just buy cloud, and I want to run cloud services like services when I run Splunk, check this out. Okay, Splunk Operator for Kubernetes. Okay, so now let's get into a more, so we have Splunk, we took a dive into Kubernetes, awesome, I can spin up 5 different Splunk pods right now if I want to, but what we did was we spun up one standalone so I could run my development lab for you guys here. And so what we did was like I showed you in that Kubernetes YAML, and I'll go back there because I know I was moving pretty quick, but that YAML that I deployed, remember? I can actually now look at it running in the cluster, right? So this is what the cool part is that I have Splunk natively running in Kubernetes now, where I can say, get Splunk enterprises. And this will change a bit in the version you guys will play with. I'm using a version behind because I didn't want it to break. So imagine this. I can go into a data center and say with one command, show me all your Splunks. Show me your papers. You know what I mean? What Splunks are you running? And so you can see here, I'm running one Splunk. And so I'm going to say, okay, well, I just met you, and I'm new on the Splunk team, so I want to know more about that Splunk you're running. Show me what you're running in there. So I'm going to describe it. Describe Matty Mo. So no, describe the Splunk Enterprise instance, Matty Mo. And now this is the equivalent of me saying, no, don't just show me that you have Splunk. That's not good enough, because I see 1 million Splunks. I talk to 100 customers a day. How does that help me? Oh, no, you want to see how we actually deployed it and what it's running? Here you go. And so this is like a shipping manifest. You know what I mean? It's like, this is the manifest that Matty Mo used, or Matt used, or Tony used, or the admin used to deploy Splunk Enterprise. And so you can see I've installed 3 apps to play with. I've installed a container workshop app that's a custom app that I built. So this would be like your personal, apps. And then I've installed app for infrastructure as well as, and the TA. And I've installed Splunk Business Flow. Now, the cool part about this is you could install all these Splunk apps directly from Splunkbase. Obviously, you're not going to do that. But you could also install it directly from Artifactory or a repo or things of that nature. Right. And so that's another benefit of using this kind of pattern instead of, this kind of sprawling issue that, you can even go see on Splunk, Splunk ideas. People are still asking for version control and running in Git and all that. And so this gets us a little bit closer. Right. So we know we have a standalone instance. Let's go. When we know we have app for infrastructure in there.
There was a question.
Oh yeah. Sorry. Let me take a look. Sorry. Stop share.
Is that the encrypted password shown there, or the real?
Yes. So this is the real Splunk admin password. Yes, absolutely. So go ahead, hit it, go in there. Because remember, I am building this to show development options, right? So hit it, do whatever you like to it. Because guess what I can do? I can just burn it in a minute, and then in a minute I'll replace it with a different password, right? And so again, where this becomes, I'm glad you brought that up. Obviously, you would never store the password in the spec. You would absolutely not do that. You would store this in a credential store, blah blah blah, yada yada yada. And so again, how many of you have Splunk instances where you keep holding Splunk to the fire to say, "Man, I want it in our, a CyberArk." You know, I want my credentials in a secret keeper. You know, I wanna do this, I wanna do that. Well, guess what? Now you can, right? Because we can just pull down from AWS Credential Store or CyberArk or from other things when you deploy it in Kubernetes, right? So yes, absolutely. Log in, knock yourself out here. It's splunk.mattimo.io, admin hello world 456, right? So go ahead, log right in, because this is why I do it, right? I want you to touch it. I want you to see what's in this cluster, right? And so, and by the way, I want you to do it because when I go to this dashboard, it will, because there's always a few of you, there's always a few of you on the call that will get smart and we'll be able to track you guys, right? We'll be able to see that when you came in, when you hit Splunk, when you logged in, all that stuff, right? Because remember, Splunk is running in a Kubernetes namespace that I'm completely logging with Splunk Connect for Kubernetes, right? So that's a great segue, right? So now that I've installed my Splunk instance and people are attacking me with my shitty password, let's go Splunk it so that we can stop them or find out who they were and Splunk it and alert it, right? So now we're in this Splunk instance that we just logged into. Again,
Matt, we don't see your screen share anymore.
Oh, sorry, my bad. I find it's easier to read the chat when I stop the share. Let me go back to the share. So, sorry, what I was meaning to show you is, yes, that's absolutely the password. And you can log in at splunk.mattimo.io. Don't do that in prod, but you can do it at home in your lab, right? Right. So, and what I'm showing you here is what we'll do is we'll go look at how we could maybe find all you guys that are actually coming in through maybe looking at our Nginx logs or anything else that's running in the cluster. As you can see, there's been a big uptick of activity here. So we can go in and take a look at maybe who's coming into Mattimo's cluster, right? Using good old Splunk, right? But let's get back on track. How would you be able to do that? How would you be able to be that confident, right? Where I know that I'm auditing all this. So anybody that logs in, I know, well, we need to Splunk the cluster, the Kubernetes cluster, duh, right? Just like anything else. So now that we have our Splunk instance installed, we installed Splunk app for infrastructure, what I did is to install on my cluster is I go into Splunk app for infrastructure and I go to this add data page and I selected Kubernetes. I already have Helm running. Again, I'll leave that to the reader to, just, this is kind of like, Helm is kind of like apt-get or like Yum for Kubernetes, right? So, but that's for another talk. I am collecting all this, I'm collecting all the information about my Kubernetes objects, the things that Kubernetes has inside of it when developers deploy code to it, so that I can see what kind of configs are running. I can do some cool security things. I give it my HEC information. So I gave my information is called standalone, right? And then I give it a HEC token, a port, blah, blah, blah. If you want to watch it live, there is, if you go to YouTube, Splunk Kubernetes, there's I'm kind of giving you a more advanced version of the demo that I already have on Kubernetes. If you want to watch the deployment of me deploying the code from app for infrastructure, like I'm highlighting here, to the cluster live, just go check out this video because it's that easy, right? And so you literally run the script. The script uses Helm to push out Splunk Connect for Kubernetes to the cluster, and you are done. So again, in the future, it'll be Operator that you would deploy that you might do this for. Today, we're using a technology called Helm, but that is as fast as it takes to integrate Kubernetes cluster. There's no 7 meetings and 5, sprints and 6 months till you get an integration rolled through all your teams. You drop it and you run, right? And again, that's only possible because of the kind of this world that this Kubernetes cluster is giving us, right? So, that's the turkey out of the oven. Let's look at my live cluster. So in my cluster, you've seen how I've used Kubernetes to deploy Splunk itself. You've seen how I have a Splunk instance running in Kubernetes now. And you've seen that I'm collecting 3 types of data from this cluster: logging, metrics, and metadata. And it's all uniting in app for infrastructure or in my Splunk dashboards, right? So let's show you app for infrastructure first. So once you follow this onboard, which is all documented in Splunk docs, if you know and love Splunk docs, you can walk through this, step by step. You'll usually work with your DevOps team and your Splunk admin together. And then you will now have, once you deploy that collector to the cluster, you will then wait a couple of minutes, right, for the data to start flowing. And now we can investigate all of our nodes and all of our pods in app for infrastructure, right? So now I have a needle stack of a bunch of different pods that are, you know, living and dead, right? Some that have come and gone. So let's look at what's actively running in my cluster right now. So if I go to status active, I am now looking at all of the Kubernetes objects that are running in my cluster. Let's look at our Splunk instance that is very poorly secured, right? So let's take a look at the Splunk Modestino Splunk instance. So you can see here I have all my pods here and a node as well. If I select one of them, it'll take me to an overview of that pod and kind of the statuses that that pod has been in and some of the high level performance information about that pod, right? So and then what I can do is I can use app for infrastructure to create logical groupings that I want to monitor, right? So I can say, hey, I'm being, you know, I just leaked a Splunk password on a recorded WebEx. We should go watch that thing now. Okay, well, let's go watch the cluster micro K8s where we are running Splunk in the namespace, or we're running in a namespace called Splunk, right? So I can just go pod names. And remember, no SPL here, right? I don't know Kubernetes. I don't know SPL. I just know what they're called. So I know that there's a namespace called Splunk. So now, as you can see, as I'm choosing these dimensions, it's actually filtering the entities that I've discovered. So let's add back the, and what I'm going to do is I'm going to say, show me just the ones that are running active right now, right? So we've boiled down a huge cluster of things into 7 entities, which you can now group, right? And so now you can see I have a group that I've set up here where I'm monitoring, you know, traffic to the cluster. And I can now analyze these groups together in a group that can then be shipped off to ITSI as a service later, right? So you can see here, I've made a dynamic grouping based on these filters. And now I can use Splunk to look at the CPU, memory, you know, the platform metrics of this pod in the new metrics workspace. And this is all the metric data that we're collecting. But guess what? I can also look at the events that are coming right out of that pod right beside it, all in one UI that I can then build a dashboard with no SPL and save to a dashboard, especially which is useful if I'm a noob, right? If I'm a Splunk noob and I don't know how to do that, right? So this is the amalgamation of that data, the logging, the metrics, the metadata all together in one UI. But before I stop for some questions, let's show you the good old Splunk way. So I'm like, okay, yeah, but I don't really like app for infrastructure, whatever. I want to look at my data in my own way. Okay. The 3 types of data that we are getting into the cluster or in from the cluster that we could use to, you know, troubleshoot or monitor are events. And yes, you can send different namespaces or different pods to different indexes, absolutely. But what you're looking at here is I'm sending all my logs to one index in Splunk just for ease of use. And so as you can see here, I can easily see my logs for my different types of containers using the source type. So we've dynamically source typed the data for you for ease of use. And so again, I can, you know, jump into my audit logs, or I can jump into my container logs, or I can jump into the metadata of the cluster itself. So maybe I want to see like, hey, I think somebody changed something. I want to see like, what was the metadata? What did the metadata of this pod look like? So again, if you come into the metadata, you go to the source type. Now I can go just investigate the metadata of the pods, and I can use this to correlate with the logs, right? So I can see like what was the configuration of that container when it was running, so that I can troubleshoot the pods that are having issues. And so I stop bouncing around. If I put the late, you know, selfish promotion, the latest blog on that mattimo.io site, if you hit this this blog right here, it's exactly what I'm describing here, just a little bit more verbose, where I'm using the data that I have in Splunk to troubleshoot errors in my containers, and then using Splunk App for Infrastructure for pre and post change validation of those changes, and making sure that, hey, look, I resolved my error and everything's running nominally. Okay, so that's really what running Splunk Connect for Kubernetes, kind of the point of it is so that you can now see your cluster like this where you can see all that traffic that's coming into our cluster, and you can Splunk it with the magic of SPL and whatnot, right? So, you know, you can see the big uptick in traffic the traffic all comes through Nginx. So I'm easily able to come in, and Nginx is running in a container, right? So as you can see, and again, there's a blog on that website that if you want to see how I Splunked and extracted all this data. But like I promised, I want to see all the traffic that's now spiking towards my Splunk instance of people trying to hack my instance. And what you can see is you can start doing, you know, ES use cases. You could start doing troubleshooting use cases, you know, really simply with this remote ADDR, you know, just simple Splunk stuff where we do like IP lookups and we start monitoring who's accessing my cluster, et cetera. Okay. A lot of stuff. I know you guys have been probably beat over the head all day. I'm going to stop there because I know there's probably some questions for sure. Let me take.
There is an additional question in the chat.
Okay. Is there a way to do multi-site indexing clusters between two K8s index cluster sites? Okay. Yeah. In theory, you know, technically, absolutely. And so again, where this actually, and sorry, the question is, you know, hey, I want to run like a, you know, a globally distributed Splunk instance, and I want to deploy those indexers across those regions. This is the cool part about Kubernetes is it really flips everything on its head, right? Like we don't really have to worry so much about things like availability zones if we have the Kubernetes API, because it does all that with your cloud provider. So for example, when you're going to see architectures kind of move to, you know, in the traditional architecture, the clustering between two K8s sites in the Kubernetes is a flat network. So when you're working on it, it just appears that all sites can talk to each other, right? So yes, in theory, clustering can work multi-site the way you know and love it. But in the future, what I think you'll probably see like later this year and into next year is you probably won't run indexer clustering anymore is the right answer, right? Because remember, we run indexer clustering for data durability and for availability reasons. And as we move to things like decoupling compute and Splunk from storage with things like Smart Store and things like that, you will actually be able to just worry about replicating your data, right? You won't actually have to run multi-site clusters or clusters at all because Splunk will just be able to be data aware. It'll just wake up and the indexers will be stateless, right? And that's the road we're marching towards. But yes, in theory, there is a way to do traditional multi-site clustering on top of Kubernetes today. It does not exist in the operator yet, but it is something that we are looking at. So if that is something you think you'd be interested in, definitely just open an issue on the repo or hit us up and just be like, hey, yeah, I'm interested, even if it's just for dev, and I want to make it multi-site, or that's one of my requirements. And then we would dig deeper with you to understand, is that really what you want? Or if we gave you data durability across global sites without clustering, would you take that? Right. And I think that's the discussion you'll find yourself having, depending on where you are in the maturity curve of Splunk. Like if you're trying to run Splunk or if you're just trying to like, you know, test and develop. Right. So I hope that answers your question. But yes, it's technically feasible. We have customers that run in Google Cloud. They rent out ahead of Kubernetes, right? Of Splunk, because I'd say our top 10% of customers, they don't wait for Splunk, right? They don't wait for Splunk support. They're going to do it. They're going to do it with the way they want to do it because they do it because that's what they do, right? And so we have customers that have been running on Kubernetes in kind of multi-site setups for probably about 3 years in different maturity facets, but nowhere near doing it well. You know what I mean? Like that's why we want to build the operators, like to save customers the pain of blowing your head off, right? So that's my long question to that. So yes, it's technically feasible. Check out the Splunk operator for how we would do that, and then look, you know, out in the horizon. Be aware that there is going to be conversations where indexer clustering is a thing of the past. Right? Okay. Any other questions? Anything else that, you know, either one of these topics that you want to just like opine on, or any content that you would have loved to double click or learn more on walking away from here, or?
If not, I'm sure there'll be some follow-up.
Yeah. Don't feel pressure here. Like hit me up. I'm easy to find. Tony knows where to find me. And again, I know this stuff is all like a lot. And I know it like is, you know, you're trying to just probably get your day job done. Never mind plan for what the future is going to look like. But I would say like as a Splunker, as someone who's been around, has been like, you know, I'm a network guy. I came up through telco, you know, there is a reason why it's hyping, right? There is a reason why it's there. It may not suit your needs today, but if you get into any topics like large distributed Splunk or multi-tenant Splunk or Splunk of the future, yeah, definitely the flood is here. You know what I mean? Like Kubernetes ain't going anywhere. It's definitely going to be the thing under there. Whether you interact with it or learn it is a different thing. So don't fear the name and the tech. It's all just Linux underneath. Honestly, it is. It's all just Linux and Go, right? It's all just a rethinking of how we run a data center such that you can deploy code with ease without having to and if anybody's deployed Splunk at large scale at an org, think about that. Think about what that paradigm is, right? Like some of the largest Splunk instances, I've worked at customers in the past 3 years. It took a year to get their deployment done. A year, a full calendar year, right? And so that is like not good for you, not good for us, not good for anybody. And so this helps us, get the customers in a way that we can deliver code to you where you aren't afraid to upgrade it. And I don't have to cry when I go visit you and you're on Splunk 6.1, because you're too afraid to touch it and upgrade it, or you don't have the manpower, woman power to upgrade it, or blah, 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 right? So this is definitely the future. Definitely dive in. And if you just want to you want somebody as emotional support as you dive into the caves of Kubernetes, I'm easy to find on the community Slack channel. And I'm happy to show you why you should care. Not just like, hey, Kubernetes is the best, let's just rebuild all the things we did. It's actually the opposite. It's so that we can stop reinventing the wheel. We can stop building 5 different Ansible playbooks for how to deploy Splunk, programmatically, blah, 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 right? And hopefully we can unify around this kind of control plane, because I think it would really benefit our customers. And obviously that's the end goal every day. So again, honorable mention out to Signal Effects. If you are looking at Signal Effects and you're a metrics shop, or you're looking at doing like performance analysis of Kubernetes clusters, I definitely suggest you check out Signal Effects. But if you're a Splunk, Splunk is what you got in the shop. We get a very powerful view of your Kubernetes environment, and more content is going to come this year on using it as we amalgamate. So any other questions? I don't want to step on the next person's time, but any other kind of topics or info that you want me to leave you before I run?
In the meeting notes, can you include Matt's email and phone number and the link to his site?
and my hourly rate. Yeah. But I am, yeah. Hey, listen, and because I know Tony and, we got connections, and hey, I mean, isn't this the user group that was like, basically fronting user groups for a while anyways? I owe you. So if you want to find me, or you just want to chat for an hour with your teams or whatever, holler at your boy. I basically probably do like 7 to 8 calls a week with customers where we're just talking. Hey, what are you getting into? What are you looking for? Maybe they just want to learn more about what the hell this all is and why should I care? So I will, the worst thing I could do is change my email address, right? So feel free to email me. Feel free to ask, hey, talk to your account team. They know where to find me. Like literally, if you just go run to your account team and say, hey, Kubernetes, they'll get scared, and then I'll show up in your account. This is generally what will happen. And so feel free to abuse that until we can kind of rally the troops where we have a lot more people to kind of get you guys on this track. So.
Great. Thanks, Matt.
All right, thanks a lot. Really appreciate this. Again, everybody stay well. Hope you're doing well. And this was really awesome being able to kind of at least meet with you guys remotely. So thanks a lot, and we'll talk to you soon.
Awesome.
Thanks, Matt.
See you, everyone.
Cheers.
To wrap up the meeting with, Splunk did go live with the new user group site. Definitely a lot better than the previous site. On there, you'll be able to see post-meeting notes. So I'll be able to write up what happened along with a link to the video of this recording and any other information that'll be coming out. And it'll be a lot easier to stay in touch with everybody through that site. It's built off of Bevy. Great interface, similar to Meetup, and a large step up from the previous one. Omaha at one point had a Beers with Engineers scheduled. That's been postponed till the summer, if I remember right. I don't think we've canceled it, but I definitely know that it's been postponed. So I'll be looking for more information like that. Otherwise, if you have any other questions, comments, hit me up in Slack, hit me up in email. Let me know what we have concern, and be looking for a post with a poll on topics for future meetings for both the Nebraska meeting and the Iowa meeting. Thanks to Nancy for joining us and the Iowa team. With that, unless there's any questions, I'll let everybody get back to their day.
Cheers. Thanks a lot.
All right, see you, everybody.